right. Hello, everyone, and welcome back to the future. To many of us, CSSinJS is about few years old, but in reality, it's over 20 years old. So the concept is really old. And imagine you just came back to the future, and something has changed in this new beautiful world of software engineering. Something is different now. We are not thinking in websites anymore. We are thinking in components. And we are basically not building websites anymore. We are building applications. So I work at the company called Grape, and we are building a chat application which is similar to Slack. And I consider this to be an application. So what is an actual difference between websites and applications? I couldn't find any good explanation to that, so I created mine. So I think that web apps have complex interactions and maintain a state on the client, while websites mostly render static information. So as I created this library called JSS, I was asked a lot, like, what is a unique value? What can it do that you cannot do otherwise with all the pre-processing tools on the server? And that I was always trying to explain why I do CSSinJS, and I was not really explaining the unique value proposition of it, because it has so many things you have to know about it that we have been always talking about unique class names and modules and variables and all that, but those things can be done on the server with preprocessing, right? So today I'm going to talk about things which I think are more unique to CSSinJS. And my agenda is publishing, theming, data-driven styling, and a little bit about the future of CSSinJS. So let's talk about publishing. Software engineering is complex. This is probably the only thing we all agree on. So the only way I know to make software engineering easier is to rely on work of each other. And the modern way to publish something and to reuse something is to use the NPM registry, which has almost 600,000 packages, which is enormous. Though the real problem with this is quality. NPM CLI is basically so easy to use that it begs you basically to publish something. So if we speak about the quality for JavaScript, we have a bunch of tools. We have linters, we have typings, tests, and I even consider runtime errors to be a quality tool, because if you handle them properly, you can make sure that your interface doesn't break and you get a notification when something goes wrong. So what do we have for CSS, which is part of every front-end package or a lot of front-end packages? This is a famous Bootstrap CSS library, which says just copy-paste the style sheet link into your head before all other style sheets to load our CSS. And that's it, you're done, right? Sounds nice. But unfortunately, there are some issues like namespacing and specificity. And now we have to do this at scale of NPM, which means we want packages which can be used all together and don't conflict, don't break each other. So don't worry, I have a new methodology for you. It's called package block element modifier. So now it's just like PAM, but it's for NPM, You can prefix every single class, every single modifier with these, and you're good, right? Well, I don't like that, and I don't want to do that. And I think ultimately it's not maintainable. So we have to do something better. And when I think of CSSinJS, I think of constraints automation. Because if you use a powerful language as JavaScript, you have the power to restrict the usage of CSS in a way that doesn't break other people's code. Also, there is another approach which is called Shadow DOM. I don't go into detail right now, but you're familiar with it. It could solve most of the CSS issues we have right now, but it didn't because, first of all, it's not ready. Second, it's not well supported, and I doubt it's fast and it will not have any performance issues in the future, because if you use Shadow DOM in order to encapsulate every component, like every button, you will have hundreds and hundreds of them on one document. So my take on this is always bet on JavaScript or any other language which will replace at some point JavaScript, because it is a more powerful language than CSS, and it allows you to avoid or fix problems you have right now or in the future. My next topic is theming. What is a theme anyways? I couldn't find again any proper definition, so I wrote my own. Theme is a configuration that defines a look and feel of an application. Let's have a look on an example. Here is Material UI library for React, which implements Google's material design. And this one is the most popular one in the ecosystem. And here how a theme looks like in this library. It's basically an object which contains colors, typography, shadows, transitions, spacing, breakpoints, and so on and so on. Lots of things. If we don't want to use something like that, we want just low-level vanilla CSS, what would we do? One of the most popular approaches is to use built-in theme, as I call it. So basically, you have this configuration, but somewhere before you do the build. And when you do the build, the theme is inside of the CSS you have produced. And so you basically load already built-in theming with your CSS. So the problem with that is, first of all, if you have many themes, you have to re-download the CSS with all of it. And the second one, the bigger one, redesign becomes complex if you have a multi-team setup. Imagine if you have a product where many teams are working on the same product, so every team is responsible for some page or some component, and now you do the redesign. You have to change something in your theme, ask every team to adapt accordingly, to create the builds, and to coordinate all this effort, and at some point you finally can build your final bundle and release it. It's a lot of coordination work. Another approach to theming is to use CSS variables or custom properties. And I quote, CSS variables are subject to the cascade and inherit their value from their parent, which essentially means they have all the same problems we have with regular CSS rules. And additionally, we have to make sure that custom properties don't collide. So we have to ensure uniqueness. We still need a build tool or a tool at runtime which makes sure that those names of those properties are unique, so we don't get collisions. And the last problem, which is the biggest one, is it is not well supported. There is no support in IE 11 and below, and so for the most production applications, it's no good. When I think of theming in the React, I think that CSS variables are a lot like React's context, and it's not just React. Many other libraries and frameworks have also a notion of this context object. So I think it is similar to CSS variables. Let's take an example. We create a theme. This one is using Material UI API to create a theme. We just define some colors, nothing fancy. Now let's use that theme. The way you do it in React with this library is you use a provider which accepts a theme object we just created, and then we wrap the entire application into this provider. So all the inner components, like buttons on this example, will have an access to the theme using the context, which means that we can change the theme anytime at runtime, and everything inside adapts accordingly. Another interesting thing about it is that you can nest providers, which means that you can use another provider inside of this provider and use a second theme or a different theme in order to style part of the page in a different way. So exactly the same component will look differently in a different part of the page. You can throw in a component and it just adapts. Okay, next topic is data-driven styling. And I know of two kinds of data-driven stylings. First one is state-based, which means basically anything that defines the state of your application can influence the appearance of the application. It could be user settings, could be weather, your mood, or whatever else. So anything that can define how your application looks and feels. And another kind of data-driven styling is streaming animations. And this is the most interesting one to me because it's really hard to do on the web. If you look at this simple switch button from iOS, it feels very natural to use. And the reason is it's not a simple animation. It's not something static you can produce with simple keyframes or something. Because the moment you swipe this button, you apply a certain acceleration to the button. And then physics engine takes this and simulates gravity on this button, so it moves in a way that feels natural to your eye because we are used to see things which act and move naturally. This is why mobile interfaces are way better than the web. They are more natural. And so if you want to do this on the web, you obviously cannot really use transitions and keyframes because if you use them, you have to know in advance when the animation starts and when it ends and how it runs. And these are informations which are provided at the moment the animation happens when user swipes or does something else. So on the web, to implement those things, you usually would use inline styles. And in React, inline styles have some overhead because React has components, and those components have encapsulation. And so to apply styles, they have to do reconciliation of the components, and then they have to apply the styles. And the styles application also, because it is declarative, it is slower, because you have to loop over objects, see what has changed, what has been removed, and remove it from the DOM and apply the new changes. If you want extreme performance, and you want extreme performance because if you're trying to achieve these natural animations, materialistic animations, you need the maximum of the performance. You cannot afford any overhead. And so as we are running, as we have to control with JavaScript every frame of this animation at 60 FPS, and we have just one thread where something else also can happen, we need all performance optimizations we can get. And so I think one feature many people don't know about is CSS object model. And the thing is, it's actually very fast. And this is an example of how the API of CSS object model looks like. So we create an element, style element. We put it to the head, and now the fancy stuff, we just insert a CSS rule into that element. So we basically programmatically generate CSS. And this is how easy it is. And if we want to update this CSS rule, we can just access it and access the style object, same style object we have on the inline styles, and just change the property. Now, this code was quite low level. You don't want to do that in your product, right? So in JSS, we have a better interface. We have function values. And function values are basically values which are defined as a function. And when you call update in JSS, you pass your data or props when it's React. And so this function takes it and reacts accordingly and returns an actual CSS value, which JSS then takes and applies to CSS_OM rule. So this is a very direct approach. It has very low overhead. And additionally, you can optimize that by simply using should component update hook and return false. So there is no React involved at all in the entire update cycle for these styles. Here's a demo. I hope it works. Right now we are rendering these objects with just JSS. Now we have 10 objects, now 14, 70. I don't know if you can see the FPS meter, but right now it's 60 FPS. Let's render as many objects so we can see the dropping frame. Now I'm animating almost 300 objects and still not quite dropping. Well, now it dropped to 50 FPS, right? Now exactly the same using React inline styles. Frame rate dropped like to 11, 10. It's 2 or even 3 times faster. Now, if you want to build some really complex animations, something very, very complex where many streams are involved, many data streams, Observables is the right interface to do so. And Observables are hopefully getting into a standard someday. So there is a proposal on the GitHub, which is under this link. So please go ahead and take a look at it and start it, because Observables at its core are a beautiful concept. Here is an example of how GSS in the version 9 is using Observables. So it's basically the same like function values. Instead, you're providing an observable. I did just a very trivial example, so you can see that it's basically an object which can receive a value. So I'm setting right now just the next value right away. In a realistic case, you would use a library like RxJS or something to, to manipulate the streams and then to return the right value at the end. And the beauty of it is also, especially because it is so simple and at its core. The only thing I had to do in order to support observables in JSS was first to identify an observable object, which is easily done with this tiny package, and then just to subscribe to the value. And once I have an update, and I see the value has changed, I update the CSS rule with this call. So that's it. That's all I had to do in order to support observables in JSS. And the core of observables, which TC39 is trying to standardize, is compatible with most reactive libraries like RxJS, Bacon, Kefir, so you can get the entire breakfast. And another thing is, observables are push-based, which means they are a perfect fit for handling events like mouse move, which are very frequent, or data stream from a physics engine. So basically, it's the right interface to coordinate the streams of all the data sources you might want to use. And also, I think observables and CSS object model are a perfect fit because they are both decoupled. Observables is decoupled from the data source, and CSSOM is decoupled from the DOM. They are both lazy. Observables don't do anything until actual events start happening. And they are both extremely reusable. For instance, the entire animation is built on top of CSS rule, and the only connection between the CSS rule and the DOM node is the hopefully generated class name, which can be passed around. You can build the DOM before or later. You can pass the class name at any point of time. You can reuse the same class name on many elements, and the styles apply. There is a lot of things you can do because of this strong decoupling. My last topic is the future of CSSinJS. And so, it's my quote. The biggest issue at scale we currently have with all CSSinJS implementations is they are not shareable without the runtime, which means, I will explain later. So the solution we currently work on is called ISTF, which is interoperable style transfer format. And the people behind it are all here. So Glenn Madden from Styled Components, or Tab Atkins, who actually works on real specifications at CSS. He wrote most of the specifications and helped a lot with the ISTF specification as well. Sultan wrote the most performant CSS parser ever, and the smallest one as well. And Phil, especially Phil, who is also a core at Style Components, he is building right now first ISTF prototype and like investing a lot of time. Huge props to him. So what is it? First, interoperable. The idea behind this word is that you can use any library, CSSinJS library, or even regular CSS to publish CSS to NPM in a certain format. And then you can consume with any other library, which means that components which has been published with styled components can now be consumed or using JSS. So you don't have to bundle every runtime for every component you might find, because we have a lot of CSSinJS libraries. And if you install components from NPM, you will find that you have to bundle a lot of libraries, and this doesn't scale. Second thing is it supports all CSS features, and also it supports all CSSinJS features, because CSSinJS has more features than CSS. It supports everything that CSS supports, and also on top of that, it has things like function values or observables. Transfer. Transfer stands for compact and fast format, because we can download it from NPM. It has to be compact, but that's not such a big issue. But we also want to use this at runtime, which means we have to bundle this and load in the browser so we can dynamically generate CSS out of it. So the best thing about it is actually it's built for parsers, not for humans. CSS is built for humans, and it has a lot of complex things a parser has to consider in order to properly parse CSS. And it's really hard. So this one is created for parsers. It's optimized to be fast for parsing, and it's basically so easy to implement a parser for it. It's no-brainer. It's like 10 lines of code. Here's an example. On the top is just a regular CSS, and down there is ISTF, which looks a lot more at the first glance, but those constants are just constants there to show. Actually, those constants will be just some number, and those additional arrays could be actually optimized. So it's just one array with a number of values. At the end of the day, all CSSinJS is about building more robust applications faster. It's really all it is about. And I have a coding challenge for you. So I love this cat. He was created by David Khorshid, and we ported this cat to JSS as it is, with all the keyframe animations and so on and so on. So now, if you go to cssinjs.org/swingingcat, go ahead, find it, fork it, and use observables in order to control this cat. Go fancy, like create some animations, like control it with the mouse or whatever you want, and make this cat do things, any weird things. And I would love to share that, and I will put all the best examples on the documentation page. Thanks, that's it. Thanks for having me. I guess we have time for questions, right?
Yeah, no. Yeah, nice talk. I say the nice JSS logo. Just kidding. When is ISTF will be a thing, you think? So some estimation?
I can't do any estimates because it's something we are working on. And basically right now it's on Phil, who is implementing entirely from scratch a CSS parser. Because of the all requirements we got, we could not use any existing ones. So he has quite a lot of work to do. So I hope his employee will give him a bit time to do that. So specification is like to 90% finished. I guess there will be some edge cases, but it's mostly finished. It's on GitHub. So we are right now just waiting for Phil to finish the implementation. It could take a couple of months or something, but it will be there. We're going there.
I have just one question. Is this mainly targeted for the web?
Well, actually no. I mean, it's universal.
Okay, so can you maybe work a little bit more on how could it work with React Native or something?
We have right now no specific plans to integrate it into React Native, but actually, if like the way we think it should work is that every CSSinJS library supports this format natively, which means that if style components already supports React Native and has all the components you can use, it will be automatically available on React Native. And that's it, because it's a very low-level format. It's just a format for transportation and parsing in an efficient way. So it will be available everywhere. At some point, you don't even know that you use it, but you use it.
There were a lot of questions on QA sessions before about using external libraries and the problems with using external libraries, and you told again the standard is aimed to fix that, but actually what I care when I try to use external library and use some components from that is its API. So I have to be sure that components that are provided can accept class names. And if they not, why I should care the class names and path them as object. So imagine if we would have some kind of typings for the component class names. So we use component, and we can just use class names as strings right inside when you use the component itself. And it could be also it could also support, for example, auto-completion, and all exposed API could be supported, and it could be cross any CSSinJS and whatever component-related applications.
If I understand right, so you're asking for an interface that unifies from the user perspective every CSSinJS implementation, right?
Yes, yes.
This is something we cannot do right now, because the reason we have so many CSSinJS implementations is that they provide different interfaces, because they look at problems in from different angles and try to, interface with the user in a different way. So if we unify all of them, we don't need all of them.
We don't need all of them.
We don't need all of them, but there are a few approaches. So, and they are all interesting for different use cases. And so right now we are just it's a process where we figure out which approaches are most popular and fit for most use cases. And so at some point there will be 2 or 3 libraries which provide the best DX developer experience. And we will have like more or less popular interfaces everyone can use. But I don't think we can ever standardize or unify all the interfaces. Too many possibilities. Is that answering that question? Right.
Okay. I can. The problem is what I see. I take in the component. I want to change something in its style in my context.
Oh, yeah.
How I should do that?
So
in some universal way.
Well, there are some popular ways, which is always accept a class name, or if you want to allow user to style inner components, accept a classes hash with all the class names, for instance. This is one. Another is always provide some theming API or overrides API, which allows the user to style everything. Take a look at the overrides and theming Material UI library is taking. I think it's one of the most flexible UIs, because just to make the point, we are using this library inside of our chat, which is not really, which doesn't look really materialistic. It's like a different kind of look and feel, but it uses Material UI, which means I could completely customize and change everything. It's basically a task for the library to be able to be customizable, not something we can standardize upon. Not right now, at least. Maybe in the future. Thanks for the question.